So in this final video in this section, we're going to be looking at lists in Python. Lists is kind of the last part of the puzzle when dealing with the basic ideas of programming. So we're going to start off with looking at data types in general. So far we've looked at a number of data types and we normally refer to these as primitive data types. Now those include lists, floats, strings, boolean, and things like that. But there are also other types which are known as abstract data types, and those are things like lists, trees, and stacks. So Python has three key data types built in, which is lists, tuples, dictionaries, and there is a fourth one known as sets, but we're not particularly going to spend much time on that. We're also not going to really look at these two yet. However, if you are interested, maybe you can. Now, a lot of programming languages have things called arrays, and in Python, lists look very much alike. They feel like arrays, they look like arrays, they kind of get used like arrays, however, they're not. So there are some fundamental differences between the way lists work and the way arrays work. Okay, the most fundamental difference is arrays have a fixed size. Okay, so you're not allowed to change the size of an array once it's been created. Also, they don't have any special functions such as append, remove, which lists in Python actually do have. Arrays need to have the size defined when you first declare them or first create them. Lists, we can start them as empty and add stuff into it. Arrays are static, whilst lists are dynamic. So we're going to be looking at lists for this presentation, but I want you to be really clear that arrays are different. Okay, so in the exam, unless they say. So let's look at a list initially. So my first list has a number of items inside it. So I've got Fred, Sue, Sally, Will, Mark. They're separated by commas. And notice that I've included them inside these square brackets. Now lists are a way of storing more than one value inside a single variable. So when I print them out like this, it will print out like this. So just literally print out exactly as you wrote it. I could, if I wanted to, just access one single item in this list. Okay, so I'm accessing 3, so my first list 3, and that's going to print out Will. You're probably thinking, hang on a second, well surely Sally is the third item. The thing with lists is that they're indexed starting at 0. So the first item is at index 0, then 1, then 2, and then finally 3 and 4. So Will is at position 3. Conversely, my first list 1 is going to be Sue, and that's where the Sue came from. So if I want to display just a single item in the list, I need to use the square brackets and say the index of the value I want to display. I wouldn't write my first list Will or anything like that. So I have to put the index of the position I want to display. So lists use these square brackets. Lists contain multiple values, and each value has an index so we can access it. Just looking at that in a little bit more detail, so you can see here each element of my list has an index. These are automatically assigned, so we don't have to manually say that's position 0 or anything like that. So in order to access a single item in the list, you must know the name of the list and its index. Okay, so if I wanted to get Mark out, for example, I need to know the name of my list, which is my first list, and I also need to know it's at position 4, and then I can access it. So as I said before, this is how this is worked. You can see my first list 1 links back to Sue, my first list 3 links back to Will. It's good to actually have a quick practice at that. I know it might seem straightforward to some of you, but do practice it, get used to writing these out, because as time goes on we're going to be adding more complexity to it, and lists are one of the elements that some people do find difficult initially. It is possible to use variables or expressions as the index, so it doesn't have to be just simply an integer number. It could be an expression or just an individual variable on its own. In this code example, it's going to print out exactly what it did in the last one. However, notice I've got two variables, x and y, and I'm using that x and y here. So it does do the same thing, but it's now using variables. Variables allow a lot more flexibility. So I can actually use variable and then say, actually, maybe I want position 1 or 2. I've got that flexibility of changing the variable. Using variables as indexes allows me to use loops as well. So this code example will print out all of the different individual names and say hello to them. Okay, so it starts off position 0, so that's the beginning of my loop. I go until the end of the loop, so I've got 4 index. My last index is 4, which is mark. So I'm going up until that. Then it's going to print out hello using that variable pos. Okay, so pos starts off as 0, so the first name it's going to say is Fred, so we're going to say hello Fred. Then that's going to add 1 line to it, so pos is going to be 1. And then it's going to say hello my first list pos, so it's going to print out soup because pos is now 1. Then it's going to implement pos, print out hello my first list pos, which is going to be Sally this time, and it's going to keep going until it's printed out every single name. So lists and loops go hand in hand. It's very likely if you have a list of items, you're probably going to iterate over them, i.e. you're going to use a loop to go over them one at a time. Okay, it's a very, very, very common code pattern. Okay, it's something that you must get into your notes. For example, let's say I've got a bunch of test scores. Okay, so I've just stored them into a list. And let's say I want to work out the average score. Okay, so I need to keep track of the total. I also need to keep track of which test I'm looking at by using a position. I've got my last index as position 8, which is why I've got that. Notice that this is the same as the last one. Okay, last one I was just saying hello to people, but I started off at position 0, index 0, and I went up until the last index. I'm then adding the total to the current total. And notice I've got the name of my list followed by that index, pos, that variable there. Okay, that bit here is exactly the same as the last one. And then I'm going to onto the next index, which is exactly the same as the last one. So there's a number of parts of this which don't actually really change a huge amount. So I'm going to circle the bits that don't really change. Then at the end of it, I can work out the average because I've got my total, and I can just divide it by the number of items I've got. So the loop is almost identical. This is why getting this as a code example into your notes is really important, because once you get your head around it, it becomes really quick to write code to do something with a loop. The difference is what it's doing inside. So to work out the average, we must iterate over every value, keeping running total. So if I asked you to work out the average yourself, you'd add them all up one at a time and then divide by the number that you've got. So now's the time to start working on some of these array tasks. So go on to IS codes, again start with bronze and work your way up to gold. There are a number of methods which you can use with lists. Now, I'm going to introduce you to 4 ones which are most likely to be used. Len, which tells you how big the list is. Append, which allows you to add something to the list. Index, which will tell you the index of a value. And remove, it removes the value from the list. Okay. Out of these, Len is the only one that you'll be able to use in the exam. These ones here, you're not allowed to use unless it tells you explicitly you're allowed to use them. So here I've got an example of using len. So rather than just putting the number 9, so divide by 9, I can say the length of test scores. And then notice here, I've also got len of test scores as well. This is a better code pattern because what happens if I add another 4 or 5 items to this list? Okay, by using len, it automatically will work. I don't need to change my code. But do notice that my condition has changed slightly. Rather than being less than equal to, it's now len. The reason for that is because it's going to give you the number of items in it. Okay, so in this case, it would give me the number 9. However, the last index is actually position 8. So it's always one less, which is why you'd put less than and not less than or equal to. So len gives you the number of items. Append allows us to add more items to a list. Okay, so here's another code example. Let's say I had this before I worked out the average, so I can add more and more items to the list. So ask them, okay, do you want to add new score? If you say yes, it will ask for a number and then uses append to add it. Now append always places it on this end of the list. Okay, and then it asks them to do again. So that's the thing that's going to get it from the start to the end. Remove. Remove will allow us to move a single item. It's done using the actual value, not the index. So I can say remove Sally, and that will just remove Sally from the list. Okay, so it's not an index, it's the actual value you want to remove. So start working on the array list task. Again, you might need to use append, remove, and length methods. Now, although this is, I do want you to focus on the exam, append, remove, and length are actually really useful in general programming terms, and it's perfectly acceptable to use these in your coursework later on. So it's worth practicing those skills. But do bear in mind that they are not allowed in arrays, and you're not allowed to use them in the exam.